Hello, hello. Here we are again, coming to you from Broadcast Team Alpha on 44 different platforms around the world. And we're going to have some fun again tonight because this time we're going to take you out into space. It's going to be good. And yeah, my name is Aage, and my co host Nori cannot be here tonight, but she will be back. And also, we are transmitting also on the Conscious Awakening Network. You got to go visit those people because they got close to 50 different shows over there, cover all the good stuff that both you and me need to know about. I spent some extensive time over there and I enjoyed every second. I'm sure you will too. And also, I want to tell you how you can get in touch with me and get in touch with Nori. Go to broadcastteamalpha.com. That's our website. And find the contact feature and send us an email. We'll get the email and we'll get back to you and see what we can do for you, answer questions or whatever you feel like we want to do. And if you are watching us on YouTube right now and you see and you would you like what you see tonight, please subscribe. That'll help us a lot. And also, Nori and I created a spiritual think tank. And we do incredible things over there. It seems like we are creating out of seemingly nothing sometimes, but it works. If you want to come and have a look at that and experience it for yourself, maybe you want to create something for yourself. That is very possible, and we do it all the time. So send us an email to themastermindconnection@gmail.com. And yeah, then I want to say a few things about our guest that is returning to Broadcast Team Alpha. I think we did a show about a year ago or so. We have Marc D'Antonio. I think I said that right. I hope so. D'Antonio. And for those of you that like to surf the web at the same time you're listening, I think his website is SkyTour Isn't that correct? Yep. He's nodding his head. It's got to be correct. All right. And then, yeah, Marc, he has a degree in astronomy and is the chief, and in the chief photo and web, he's a web and analyst. That's the word, from MUFON. And also a host of SkyTour Radio on KGRA, and the creator of SkyTour LiveStream with Marc D'Antonio. So also, that is a group, live deep sky telescope observations on YouTube, and you can find there also. And there's people that can get lessons, and you can see the planet and you see cosmos there. And it is very interesting looking out into the sky because sometimes you see things that shouldn't be there. And he has investigated and the evidence of UFO sightings, landings, personal contact. And then that is why he also is convinced that ETs are real. They're coming here to visiting. They're making contact from time to time, and they are coming back. So tonight we're going to take you into the heavens because there is some objects, big objects that is coming into the solar system, and we wonder what it is. If you look on YouTube, you gotta watch out for the fake ones because they are saying, "Oh, it's a spaceship." They, credible people. They're using the names of Elon Musk. It says this is a spaceship. Other people they're saying, "Oh yes, this is a spaceship." We can see the lights on the side and all kinds of goofy stuff. So you gotta watch out for those. because tonight we're going to hear it from the scientists that has a close circle of information available. And we're going to hear what they say, what it is, or what it could be. And maybe it's not an alien race coming back, or maybe it is. Welcome, Mark. Let's hear on that.
Thanks, Aage. It's so nice to be back. I think you're right. It was about a year, maybe a little longer, that I was on with you before.
Yeah.
And it was a great time. It was a lot of fun. And
Yeah.
it really was. And, one of the things that's interesting about this cosmic interloper that's in our solar system right now is it's already past Mars, and it's already gaining a lot of notoriety because of how it's moving in our solar system. Avi Loeb, who I know Avi, and we've worked on some programs together. Avi is usually a very considered opinion. And in this particular case, he's just being very clear that in this particular, with this motion of this object, there are anomalies, and there are anomalies. But that said, we also have to consider where this object is coming from. And that's part of the problem as well. We have never had an object come in literally along the plane of our solar system like this is. And it's really strange, I should say, as how it's coming into our solar system, because it usually would mean that if you were at an alien race and you want to locate another planet that you could go to, what would you do? You'd send a probe to that solar system, right? That star system, right? You would. That's what you would do.
Yeah.
You send a probe there. And if you sent a probe there, you would probably make sure that you had some pre-knowledge of what's there. And if they have the technology, which is far in advance of ours, then they could, in fact, look at the solar system they're going into. And then to get a close look, they would send a probe. Now,
Yeah.
As it's coming through our solar system, it passed Mars on October 3rd. Okay. It's going to pass the sun in December, but in November, it's going to pass by Venus. All right. And then on the way out, it's going to pass Jupiter on the other side of the solar system where it is. So it's going to be winging its way past 3 major planets in our solar system. And
yeah, what are the odds of that?
Well, about 0.005%, to be fair. Okay, the odds are slim, right? Which is interesting. Now, is it coincidence? Well, I think about it in terms of until further notice and until further detail and further information comes through, I'm going to say it's a very powerful coincidence. And then I will open-mindedly wait for something other than that to be true. And that's all Avi's actually said. Avi Loeb has not said they're aliens. They're aliens. That's what the internet has been saying. Okay. People who get their degrees on Google, okay, go out there and make these postings that sound so authoritative, but they never, that's authority they haven't earned. And they just looked at a video from someone else who doesn't have any authority about it, and they internalized it and made it their science, which is absolutely incorrect. There's a lot of reasons why Atlas is doing what it's doing. We think it's way larger than we thought initially, and there's a reason for that, which we can go into. I mean, it's coming in along the plane of our solar system, and therefore, and when I share the screens at some point, maybe I can show you a couple of images which will point out why it's coming in along a plane of our solar system, because the galactic plane's like this and our solar system's like this. So you might say, well, wait, if it's coming in like this, how could that be? Well, it's not. It's coming in like this. It's coming in across the plane of our galactic. Here's our galaxy. Here's our solar system. It's coming in this way and going out. So it is coming from the galactic plane. It's just it's making a slice through our solar system that's going to take it by the planets. And it's really interesting that it's doing that.
Yeah, but there's some anomalies that cannot be explained. And I saw one scientist said that it looked like it is intelligently guided because, first of all, he said it's a constant speed. And I think there also was in that paper that he wrote that said that normally when you get closer to the sun, the speed will change.
Yes, and that is true. And I believe that Atlas is accelerating, and as it gets closer to the sun, it will accelerate faster. And right now, it is accelerating right now. It is going faster and faster every second. As
Okay.
it's going to reach the sun later this month, right? It's going to be passing the sun and coming out the backside. Another one of the conspiracies, by the way, is that NASA has gone dark. They're not showing us anything with Atlas. Well, that's
Yeah.
because it's over near the sun and we can't see it in the daytime sky. I mean, it's literally that simple. Um, so what's happening though? There's weird anomalies with its motion that were discovered. Okay, now
Mhm.
the interesting thing is that as it's approaching the sun, the sun's pull is pulling it in. It's going faster and faster and faster. However, it's also got a lot of gas and dust around it. Now, why? Because as the sun warms this thing's surface, this material is shooting off like little gas jets, kind of like little mini rockets.
Mhm.
This is what happens on comets, right? And we saw that with the Rosetta mission in comet Churyumov-Gerasimenko.
Yeah.
When Rosetta orbited this comet, it sent a little lander down, but we could see jets of dust coming out because gas trapped inside was shooting out as soon as it was released by the sun's warmth,
Yeah.
heating and sublimating the ices and the surface and then the soils. But that's happening to a great extent with this comet. We're seeing a lot of this dust and a lot of this gas. So the question is, why aren't we seeing any motion of the comet due to those jets? Every comet changes its trajectory, because
Mhm.
it's spewing these little rocket jets of gas and
Yeah.
dust. But this one doesn't seem to be doing that. It seems like these jets are having negligible effect, even though there's a lot of this stuff outgassing, as it's called, from this cometary surface. And the reason seems to be that it's much more massive than we thought. Comet nuclei are maybe a few miles across. Okay, this one could be up to 30 miles across. And so, with a nucleus, a central rocky core that is 30 miles in diameter, it'll be much more resistant to motion by those little jets
Yeah.
pushing it around. So, that could explain, in fact, that is the hypothesis as to why this is not moving, is because it's actually more massive than we thought. So, it's not reacting to the jets. It's like it's trying to use like a squirt gun. If you're sitting on top of in a car in neutral, you try to use a squirt gun to squirt water in one direction, and you're not getting any kind of propulsion in the reverse direction like you should. Newton's
Mm.
third law: for every action, there's a equal and opposite reaction. So if you throw a 10-pound weight out in front of the car, okay, the car tires might rock a little bit if you throw it hard enough, but a squirt gun will do nothing. So
Yeah.
the 10-pound weight is kind of like what you expect comets to be propelled by and moved by, is little jets moving the car, or comet slightly. But it's so big that it's like these jets are like squirt guns.
Mhm.
They're not even propelling anything so much. It's very puzzling to astronomers, actually.
Yeah. And let me just dwell on the anomalies a little more because
Yeah.
we don't know what is true because there's so many lies out there or fake videos and stuff. But one of them, they credited to a scientist and saying that he had sent an electronic signal. They transmitted an electronic signal in the direction of Earth. Is there anything to that there may be an electronic signal possibly in the very low frequency range, which is commonly used for deep space communications?
I'm going to just be blunt about this, and not with you personally, but with the concept that you're relaying here.
Yeah,
This object is basically being studied by telescopes all over the planet, including the James
yeah,
Webb Space Telescope and the Hubble Space Telescope. And so when people get a hold of little nuggets of information, they interpret them their own way. And they might take a interpretation of the data that was received coming from the comet, meaning it took a photograph of the comet. That's data being received by the telescope,
yeah,
and contorted that into this is information coming from the comet, and it looks like it's intelligent. No, it's actually not moving any different than an object would move when it's being uh, propelled by the pull of gravity on it from our
mm,
sun. It's not
yeah,
moving any differently. What's again the interesting part, and people are making more out of this so far than they should because we don't have evidence for it. But hey, that's the internet, isn't it? That's social
yeah,
media. Turn it into something where you'll click on it and read my story, right? Or,
yeah,
let me do a video that gets 1 million likes, and get me some cashola, whatever. When you're up against that, people tend to not tell the truth. And there's a lot of people out there that are claiming certain scientists are saying certain things. And in fact, they're not. One, Elon Musk, okay,
yeah,
was supposedly claimed that something was happening with Three Eye Atlas. That's false. Others claimed Avi Loeb made comments. That's false. Okay. Those are sensationalist uh, 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 sensationalist, statements where they actually warped what people say, right? They made claims that other people out there said something like Brian Cox said something too, apparently. No, he didn't. Okay. He didn't say anything. No, none of these folks have said they're alien spaceships. Not a single one of them
yeah,
have said that.
yeah,
It's just been an interpretation of the media, the social media, that's having a field day with this. You know, I wrote an article. I actually see that's me right there. Sorry, let me fix that. There we go. It'll come back in. See, the comet's getting in my way, as you can see. So I'm
yeah. There you
actually
go.
the comet was in my way. Um,
Yeah,
but social media has been responsible for a lot of these theories. And I'm open minded, but I'm not going to be ridiculous about it either. We don't know details about it yet because it's actually not going to pass closer than 170 million miles from Earth.
hmm, yeah,
Okay, and it's going to be, you know, 60 million miles from Venus, 80 million miles from Mars, I believe. It's actually not going to be anywhere near us. So I don't think that uh, we're going to ever get a good view of it. Um, I do know that the Juno probe at Jupiter, it's already past Jupiter. I'm sorry, it's not past Jupiter. It's going to be going by Jupiter. It's already past Mars. And the
yeah,
Mars high rise craft, I believe, took an image of it. And even that sparked a whole bunch of internet fakery. For instance,
yeah,
whenever you take a time exposure of a moving point object in the sky, right? A time exposure, like say a 4 second shot of something moving across the film, okay, or the film. I'm sorry, the sensor. You have all the dots of the stars, and then you have a line. Ooh,
hmm,
look, it's a cylinder. No,
yeah,
no, it's a time exposure. It's a point source moving quickly through the field,
yeah,
and that's what they showed. And of course, it was green. And the reason it was green is because now more comet properties are starting to show up with this thing. Okay, cyanogen, which is a carbon atom and a nitrogen atom together, and then another pair bonded to each other. So it's CN. You have two of them, or C2N2, however you want to say it. And cyanogen is something, the molecule, its spectrum emits green. So when we see it, it's green. And that's part, and the reason for that is the carbon atom in there. So
yeah,
clearly, you've seen the green, right? I mean, you know what I'm talking about.
yeah. The two carbon atoms together. That's C2. That
Yes.
create the green aura of around it.
Yep.
is from
And
what
when
I
you have,
remember. Yeah.
yeah, you're right. And when you have cyanogen, which is a carbon and a nitrogen atom, and then another carbon and a nitrogen atom together, so they're linked as a whole total molecule of 4 atoms. You also get a green spectrum the same way for the
Yeah.
same reason. Yeah.
Okay.
And yeah, so I mean, and we're seeing carbon dioxide ice, a lot of it. Okay, we're seeing water ice. We're seeing carbon monoxide. We're seeing carbonyl sulfide, which is another compound that just has a sulfur atom in there. Not unexpected for something that's been around for what could be 7 billion years, 1.5 times the age of our solar system. It's had plenty of time to grow out there in interstellar
Yeah.
space, right? Yeah, but
Yeah.
they
And
think it's. Go ahead.
I saw a video on YouTube also where it said that Elon Musk has sent a rocket out there to actually collide with it. But
Yeah,
people, think about it. How long time will it go to send a rocket from here to the other side of the sun where Mars would be?
can't do it.
Yeah,
Yeah,
we
it
got to
takes
use our
months to
head a
get
little
there.
bit. Yeah,
Yeah,
we
but
got to
people,
use our.
we do. We have to use our heads, like you say. I mean, to step on you there for your what you're saying, but we need to use critical thinking, and critical thinking is very important in this. And if people want to say that there are some anomalies, let's talk about the real anomalies. Let's talk about why it's coming in on the plane of our solar system. That we don't know. A true
Yeah,
anomaly. Okay. Let's talk about why it has so much CO2 ice, carbon dioxide ice, dry ice on its surface. It's got an extraordinary amount. Now, that could be because it's more massive and has thus more CO2 ice on its surface. Maybe. Okay. That's interesting. That's a true anomaly. Let's talk about why it doesn't show what they call non gravitational acceleration. Gravitational acceleration is what it is showing, the sun
yeah,
pulling it in faster and faster and faster. And it's doing that right now. Okay. But non gravitational acceleration, those are those jets that the comet gives off when this stuff comes out. And because we have so much stuff around this tiny little nucleus of the comet, which might be, say, 30 miles, in size, which is not small. Okay. We have this gigantic multi-million mile cloud of gas and dust around it. And so, with that much stuff coming off the comet, you would expect that it would have these jets that would change its trajectory, but it
mhm,
doesn't. And so, non gravitational acceleration is negligible. We don't see it. And that's what led Avi's team to actually do a study which showed that it's much more massive, probably, than we realize.
yeah,
And that's okay, because if it's coming in on the plane of our solar system, it means in this particular case, it's coming in from the galactic disk, the disk of dark dust and gas in our galaxy, where the dust and gas is the most dense. So for the 7 billion years it's been traveling, Augie, this thing has probably been building itself up and getting larger, and I think that's part of the reason that we're seeing what we're seeing. We've never had an object
yeah,
that came in at this level like this through the
yeah.
plane of our solar system like this.
There is one more anomaly that becomes apparent to me. Maybe
Yeah.
you could explain this, and that is that when you take a picture of it through the, let's say, the telescopes, it shows up as a big, a blob. But
Yes.
it is putting out a lot more light than it would by just the reflection from the sun. So
Yeah.
there is light created in or around this object. Otherwise, it wouldn't be as bright because just a reflection of the light from the sun would be next to nothing at that distance.
Well, I took a photograph of it with our SkyTour LiveStream telescopes,
Hmm.
which I'll show you when we share a screen at some point.
Yeah,
Um, but I want to make it clear that this object is more massive than we thought. Therefore, when stuff is evaporating off the surface, basically, and going out into the space around this comet, it's going to be a lot more of this material, a lot denser because it's so big. And so therefore it's going to be brighter. So it's not giving off its own light. That's one of the myths that grew on the internet and in social media as well. And so it's not giving off anything but reflected light, but there's a lot of mass of stuff out there that's reflecting back. So that's why it's so bright. Okay. But and what's being reflected off is going to be particles of dry ice, which is highly reflective.
Yeah.
Um, and there'll be dirty particles too, like nickel atoms were also found in its spectrum, which was odd. Um, we wouldn't expect to see nickel without seeing iron as well, and there's really very little iron, so that is a true anomaly. Okay. However, we have never had a comet come from out of our solar system that has this type of trajectory.
Hmm.
So this is new for us. And so, um, although we'd love to leap to the conclusion and say, hey, maybe it's an alien race come to save us from our own stupidity, you know,
Yeah, well,
uh,
hey, I'm all for it.
I'm all for it too. But I don't feel that it's probably gonna. I don't think it's gonna be these guys. In this particular object, I think this
Yeah,
object is actually a true interstellar comet. I don't. So far, it doesn't have anything in it that says it's an interstellar spacecraft. In fact, more
yeah.
and more, it's looking like an actual comet.
Space object, yeah. But then again, I think the rumor says that there was a NASA scientist that this is one object, but there are 7 or 6 or 9 of them coming behind it also that they can see. What do you
Well,
know
it's
about that?
I do, and okay, it's actually not behind it. Okay, here we go again. It's not behind it. And more comet dust in my way. Obviously, it got blurry. Uh, it's actually that there's other comets that are in our solar system right now, and
Mhm.
at any one time when we're doing our sky tours with our remote observatories and showing people things, if there's a comet nearby, which there usually is, we'll go look at it, and people can see this little fuzzy dot of a comet out by Jupiter or Saturn and say, "Oh, that's where it is. Look at that." Okay, so there's lots of comets in our solar system at any one time, and so we can actually show people those comets, and and we tend to do that. We want people to actually see them, and people understand what we're looking at. It's very important that they understand that. Um, so I don't find it odd, and I did hear that 7 other objects rumor. And 7 is one of those big, mystical numbers that people like.
Yeah,
I'm surprised they didn't say 666 objects. Maybe that number was too high for their idea to work. But
yeah, and you got to count.
and then you got to count. That's right. Yeah, but there's a number of comets that are in our neighborhood. There always are. They're always out there. People have
Mhm.
to remember that our solar system, okay, is here, okay, and then we have outside the solar system is another belt called the Kuiper Belt,
Yeah,
Kuiper, and the Kuiper Belt, for those listening or watching, the Kuiper Belt is a area of icy bodies. Okay, there's little planetoids out there, and like Kaor, Sedna, others that have a name. Okay, and these objects are in an orbit that's very slow around our sun, but then way further out in a halo, a spherical area around our sun, is what we call the realm of the comets. It's a set of icy bodies that are loosely held to our sun by its gravity. And over millions of years, a star passing by near our sun over millions of years could pull one along. And when the star passed, it would fall back in and maybe start the long journey of a million years or more into our inner solar system and become a comet that we could see. And so most of our comets come from out there in that what we call the Oort cloud. That's Oort, Oort cloud. And that Oort cloud is neat, Augie, because we know how fast an object should move if it's dislodged from the Oort cloud and starts its long journey getting tugged by the sun back into our solar system and the inner solar system. The cometary body from way out there can only reach a certain speed. It can't go faster. By the time it gets to the sun, it will have already gone as fast as it possibly can go. And so that is how we determined this was an interstellar object at all. All right, because it's moving much faster than a comet at that distance would be moving if it was something that came from our Oort cloud. That's how we know it's interstellar, because it's moving way faster than it should for the location in our solar system. And like the Oort cloud would have spawned something moving slower at that level where we're seeing it now. So this spawned a myth that the object is changing its speed, or the object is moving way faster than it should. Not true. It's moving just as it should for an interstellar object. Oumuamua, one eye, one meaning the first and eye meaning interstellar, one eye, Oumuamua, was moving very fast. We didn't even see it till it was already almost gone. Okay.
Yeah.
And then 2I, the second interstellar object, was a true comet, smaller, called Borisov, Borisov, Borisov. And we had a little bit of a glimpse of that too. And then 3I Atlas is this one. Now, Atlas is the name of the planetary, planetesimal telescope camera system that is doing the search. It doesn't have an official name yet. So 3I Atlas is what it's got now. Who knows if the International Astronomical Union will give it a real name, like they gave Oumuamua and Borisov. But maybe they won't, because 3I Atlas is now in our culture as 3I Atlas, right?
Everybody knows it.
Everybody knows it.
Yeah. But if let's say a big object came into the Kuiper belt and collided with something, that could also spit out an object like this one going into the solar system and becoming one of the objects that we are looking at right now, couldn't it?
Well, we would, if there was a massive object coming into our solar system, the first thing we would notice is that Jupiter, Saturn, Uranus, and Neptune's orbit, maybe Pluto's, would be altered slightly. We can keep really good tabs on our planetary orbits, and if there's a slight gravitational tug from something other than what we know, we'll see it. And there was none of that seen. And so if let's go to your question though. Let's say something did come in, and it came in with the speed of, say, 3I Atlas, coming in interstellar, truly interstellar, coming into our region. Okay. I just like refocusing on my fingers, apparently. I don't get why my camera's doing that. So sorry about that. Anyway, but let's suppose we did that. Let's suppose this object came in, struck a Kuiper belt object out past Pluto, and did a ball bounce, a typical elastic collision, a perfect elastic collision with something, and sent it in. That could send something in. Would it come in directly on the plane of our solar system? Probably not. It'd probably go off in some random direction. So we still have that plane of our solar system thing to think about.
There you go. Yeah.
But I can't say that it couldn't happen, but the only thing is we don't see any movement that's out of the ordinary for any of the larger planets or Pluto, which is kind of like they're sentinels. We would know.
Yeah, I see. And now I see that we are down to the bottom of the hour. So for those of you that joined us late, we are talking with Marc D'Antonio, and we are talking about this object coming in from deep space, passing through our solar system, and there's so much controversy around it. And we're trying to get an idea from scientists, what they see and what they know, instead of all the armchair researchers out there that making weird videos saying that, Elon Musk sent a rocket out there that hit 3I Atlas and it broke up. I mean, 6 months to go from this place to the other side of the solar system to even hit it. We didn't know about it 6 months ago. So just watch yourself out there when you watch this thing on YouTube, because
Yes.
there I bet about 75-80% of it is probably not so. And I'm guessing on that number.
You're very close.
Yeah.
Except my posts. My posts that I put out there are taken from true scientific knowledge that we have. So I don't leap to conclusions, but I'm open to other conclusions.
Yeah. And the thing is, like you mentioned, really in the beginning of it all, that if an intelligent race was going to consider us for something and wanted to know what we were doing, they would send a probe through. A good way to
Yes,
do that could be to attach a probe to an asteroid and just
that's
send
right.
it through and
Maybe
take
so.
pictures, yeah, measurements, and just do whatever they want to do.
Yep, I certainly think so. I certainly think
And
so.
yeah, now we've heard about 3i Atlas, but and there are pictures of it out there. One of the
Yeah.
pictures I saw on YouTube was a long cigar with windows on the side of it. How about that? That is really neat.
Yeah,
And
that's one I saw. I saw another one which is hilarious. Um, in the late 60s, we had the Star Trek episodes, Star Trek, the original series. Uh, we had Captain Kirk, Scotty, get us out of here, right? We love Captain Kirk. He was great, you know? And in one of the episodes back then, there was an episode called The Doomsday Machine. And it was a long,
oh,
conical thing, right? That
hollow.
would eat planets.
Yeah.
And don't you know, someone seized on that and actually tried to make that Atlas, and they said it was Atlas. I am just
That's really good. All right, but I would like to see some of the pictures that you and other scientists have taken from it. So could you
okay.
maybe share screen and show us the pictures?
I sure can. I will. Just a sec. Let me get this here. Let's do this. Okay. You should see my screens now.
Yeah, there we go.
Yeah, you see them? I just need to. I'm not sure which one you're seeing. You're seeing the orbit right there, the trajectory.
Yeah, yes.
Okay.
See the
Okay. Good.
orbits.
Yep. That trajectory is really interesting, and the reason is because I don't know if you can also, I think, see my cursor, right?
Yeah.
Okay, good. Right. So 3i Atlas is out here, and it's come in. All right. It's already past Mars. All right. And it's going to be closest. It's going to be closest to the sun. Uh, in let's see. It's going to go. I'm sorry. Go past the sun. Closest approach to the sun is going to be shortly after it gets past Venus. So December, it's going to be closest to the sun, right? Actually, December 19th.
Right.
See, going from my head. Okay, December 19th, it'll reach the closest approach to the sun, and it'll be 130 million miles away from the sun at that point. Okay, now when it went past Mars, it was at closest approach to Mars was 18 million miles. So relatively close, I guess. And then when you look at what's going to happen after that, it's going to pass by Venus on its way out. And when we say pass by, we mean 60 million miles from Venus.
Okay.
Okay. All right. And that's going to be here. Venus is here. And then you're going to see it going to go past Jupiter at the and its final mission and its final
Mm.
journey out of the solar system, and then come out. So you see, it's coming in from slightly above the plane of the solar system. Then it's going to go down, then come down, and go out. A little bit below the solar system. So it's slightly above, and then it's going to go out slightly below. So it's coming in a slight deviation, not exactly in the plane of our solar system. So that's this particular image showing the trajectory. Okay.
Yeah.
And we're here right now. It's right about here. So it's come from all the way out here. When I took the picture right about where it's listed here. My photograph I took was
Ah,
here, which I'll show you in a minute. Okay. Now, can you see this red square?
yeah.
Okay, there it is. And this is a star field in the constellation of Sagittarius. I used a special filter to get rid of most of the stars, but allow me to see this object moving back there. And that little dash, that little tiny dash right there, that is 3i Atlas captured amongst the stars of Sagittarius, and
Man.
that's with our ordinary that's with our remote observatory. Now, I live in Connecticut, and this telescope I used was out in Benson, Arizona, at a 3,600-foot elevation on a mountain or a plateau out there that we share with 9 other professional astronomers. And
Yeah.
so we turned our instrument to it, and we got this image of it. And this is, I think, a really beautiful image of 3i Atlas.
How in the world did you find it?
Oh, I knew the coordinates, and our telescope is very accurate. So I
Uh-huh.
managed to locate it, and I took a time exposure. This is a time exposure. In other words, we have the telescope guiding in one particular location. So it's staying on one set of stars. And anything that's moving will show up as a little line. And that's just what we got here. It's the only line in the
Yeah.
entire image, and it's exactly where 3i Atlas is supposed to be. So we were able to catch it. All right. And that's when it was out by Jupiter, or say Jupiter's orbit. Jupiter was on the other side of the sun at that time, but it was all the
Mhm.
way out by Jupiter's orbit. That's over 5 astronomical units away. An astronomical unit is 93 million miles. So you can do the math. We're looking at almost 500,000 miles out or
Yeah.
more. So then,
Are you gonna take another picture when it gets closer?
well, it's actually too close now. I tried a few nights ago, but it sets right after the sun sets, so it was still too bright a sky.
Oh,
But it's brighter now, so I should be able to. This is the James Webb image of it. We can see the James Webb imagery here. All right, really cool. Um, and you can see it's orange only because that's what the James Webb um, um, images in it, images in the infrared. So we're looking only at the heat, only the heat only, nothing else. It doesn't show us shapes unless the shapes are illuminated by the heat coming from the object. So we're seeing basically the effect of the sun's light on this object. It is getting warm. And that's obviously different from if it was way out in deep space. If it was further out there, and the James Webb took a picture, it wouldn't see much because it would actually be cold and wouldn't show up against the background of space. But as it warms up, as it comes in our solar system, we can see it. And these are the different wavelengths that were utilized to see what was going on here. Okay. So,
yeah,
so there are 4 different shots of it in 4 different wavelengths, actually. So it's pretty neat. And that's, uh, that's the James Webb. Now, to the ordinary person, they just want to see starry skies and beautiful images that look like the Doomsday Machine from from
uh-huh,
Star Trek. But that's obviously not what we're gonna see, right? The reality is different than science fiction. But I
yeah,
will say that we're looking at something that is really um, different. It's odd. It's something weren't
yeah,
expecting to see, and I think it's a very cool object.
yeah. How the telescope you have? How many magnifications is that?
This one right here, the current magnification on it is it's it's running at what's called f7, which is the focal length. I'm sorry, the focal ratio, and it's running at a focal length that's around 1800. So what does that mean? Well, in terms of in terms of the uh, object, we're probably looking at a magnification, because I'm just looking. I don't have an eyepiece in there. I just have the camera mounted on the back of the telescope. So we're probably looking at a magnification of maybe 100 times, maybe 75 times. I have to work that out for you. I haven't worked it out.
Uh,
But our other telescope is a wide field system that's 200 miles away from this one. And that one, we're looking at several degrees of sky, as we look in the through the camera. We're seeing several degrees. We're seeing 3 full moons of size by 2 full moons tall. Okay,
mhm.
so it's really quite big. Okay, quite a view for that telescope. This one is the narrow field system, and this is the one that we used to capture that image that you're seeing right there with the
So
red square.
technically, I should be able to find that one. I have a telescope here that magnifies 300 times.
Yeah, as long as your telescope is big enough in aperture to capture the faint light that's coming to us from that object.
Yeah.
Yeah. So after this guy, we have this, which is probably the best illustration of how we're situated. We're about 62 degrees above. This is the galactic plane. This is where all the gas and dust lives, and
You
we're
know,
situated.
the blue
What?
line?
Yeah, the blue line is the galactic plane right there, and you can see the galaxy kind of behind it.
Okay.
Okay,
All right.
and our solar system's like this. Okay, and
Mhm.
Earth is sort of like this. Okay, now this is an exaggeration, of course, but on edge like this, if we say, well, it came in along the plane of our solar system, it came in this way.
Yeah.
Okay, and it's going through, so it is going to go through the plane of our solar system. Again, this is 3D. We can't show this in 3D. The galaxy is big and expansive, so it's coming in at a slant angle that takes it through like this. All right, and it's at that trajectory I showed you in the previous diagram. The trajectory is called a hyperbolic trajectory, meaning it's not going to be bound by the sun's gravity. It's a
Mhm.
one-time visitor to our solar system.
Yeah.
So it's kind of cool to see something we'll never ever see again. you
Yeah. It's
know?
going somewhere else.
Yeah. And where is that somewhere else? No, that's a good question. You know, we
Yeah.
can't really say. We don't know, you know? But this is the image that means the most to us because it really lays it out for how it's really moving through our solar system, the plane of our solar system. Because our solar system's not aligned with the galactic plane. Our solar system's like this to the galactic plane. But if we went sideways, you can see that the thing could come right through the plane of our solar system, and that's exactly what it's doing.
Mhm.
So,
Hmm.
yeah, it's a really neat object, I'm telling you.
Yeah. There's a lot of things floating around in space. I also read scientific reports saying that there are rogue planets out there that just they're traveling through space,
here,
but they are
really the
not
sky
connected
is the
to a
limit.
sun
And the beautiful
with
thing
an
about
orbit.
this
They're
whole
just
That's
floating
correct.
empty, I mean, through space.
Yeah, we always thought as astronomers, we always thought that there might be rogue planets associated with certain star forming regions where we know planets are probably forming. We could imagine that in the early life of a solar system somewhere, a star system somewhere, that planets, before they found their final orbits, could end up getting whipped out of their solar system. And we found some of those in the Orion Nebula, kind of in that region of the sky. So there are rogue planets,
Yeah.
planets without a star.
Mhm.
Now, they live in perpetual darkness. They're probably ice balls, and thus they probably don't harbor any form of life. Now, I say probably. Why? Well, I'll tell you why. Because we've been fooled before. We didn't think there was life at the bottom of the deep ocean until we discovered there's life at the bottom of the deep ocean. In
Yep.
fact, lots of it at these hydrothermal vents, these vents spewing mineral laden water that certain bacteria love to eat, which spawned
Mhm.
a whole bunch of filter feeding creatures that love to eat the bacteria, which spawned a bunch of creatures that love to eat the filter feeders. you know?
Yeah.
So there's a lot of stuff that happens that we didn't expect.
And I know
Now,
NASA did an experiment also where they took there were some little bitty creatures that they took in the space shuttle went up there, and they left the outside open, and they lived in vacuum.
you're
Uh,
talking about tardigrades. Yes.
yes, that's the one.
Yes.
Yeah.
Tardigrades are amazing little creatures. They can go into a state called cryptobiosis. Now, what that means is, and you may know this, Augie, but I don't know if your listeners do, your viewers. Um, Cryptobiosis is a condition where if there's not a lot of food or water for a creature, they can somehow go into a hibernating state. And a tardigrade could be in this state for like well over 50 years. And
Mm,
then all you have to do is add a good environment, some food, and some water, and they come back to life. It's like
wow.
a coma that you mean to go into,
Yeah.
right? It's kind of interesting. Yeah. So
Yeah.
there could
That's
be like,
that's
yes, those are called extremophiles, right? Where they can live in these
yeah.
extreme environments. So we call them extremophiles. And
Mhm.
we found them in Lake Vostok under the Antarctic ice. Okay, Lake Vostok was a lake that's it's a more than a mile or two down in the Antarctic ice. It's been sealed
Yeah.
up for a hell of a long time, and they still found over 3,000 different species of creatures living in that lake when they drilled a hole into it.
Yeah.
So life will find a way, won't it?
Yeah. And that is what we know about. What
Yes, that's
about
right.
what we don't know about? What if there are creatures, bigger ones, that have found a way to adapt themselves on the surface of a planet that has no light, that has maybe an atmosphere of something, an environment to where they can exist without having actual physical light? We never know, do we?
No, but because creatures live at our deep sea vents like that, okay, we know that they're not using the energy of the sun. That's photosynthesis, right? Where they use the energy
Yeah.
of the sun to create sugars and so forth, like plants and
Hmm.
chlorophyll, etc. Um, and plants do that process of transpiration and respiration, where they will create oxygen, right, while eating carbon dioxide and vice versa. Well, anyway, at our deep sea vents, this life was just so plentiful that it was really interesting to study. And so we also realized, hey, Jupiter has a moon called Europa. And
Hmm.
Europa is covered by a thick mantle of ice, a few miles thick. Europa is 2,000 miles in diameter, roughly, a little less. And that's a little less than the diameter of our moon. And so Europa could be one of these places harboring extremophile life of some kind. Now we know Europa has water underneath that ice because we have geysers coming out of
Yeah.
Europa in various
Hmm.
places, and those geysers contain uh, carbon compounds and other compounds that indicate that maybe the building blocks of life are down under those ices. So that means that there's probably potential hydrothermal vents there too. And we know for a fact that there are even further out in the solar system at Saturn. Saturn has a tiny moon, 300 miles across, and it's called Enceladus. And on the south pole of Enceladus, Cassini, winging its way before it was deorbited into Saturn's atmosphere later on, it went across Enceladus and noted that there were various hot spots on the southern hemispherical region, southern
Hmm.
pole region of Enceladus. This meant that we probably had um, hydrothermal vents underneath the
Yeah.
ice of Enceladus. And this was a really important finding because that means that maybe we have extremophile life living all the way out at Saturn. Now you might say, well, it's cold out there. Yes, it is, but not
Yeah.
under the ice potentially. Europa's also in a frigid zone, right? Because the whole surface is covered with ice. But when you get underneath the ice, guess what? That planet, that moon is being needed by the gravity around it. We have Io, we have Callisto, and we have Ganymede and Callisto. And they're, as they go around Jupiter, they're tugging on Europa at Jupiter, and they're kneading it like bread dough, squishing it. And Jupiter's
Yeah.
gravity is doing this too. So this kneading process creates heat inside. And so Europa will forever be warm inside. There's a place inside Europa's oceans under that surface ice, which is probably 75-degree water Fahrenheit, probably 80-degree
Yeah.
Fahrenheit water. So more than conducive to life as we know it, because
Yeah.
life lives in much colder temperatures here.
Yeah. And again, that is what we know. What about what
Yes.
we don't know? What
What we
if
don't
there
know.
are
Yep.
an alien race that created a base, let's say underneath the ice, maybe like they did a long time ago in Antarctica,
Yep.
or maybe create a base where they can live in an enclosed environment that is conducive to life as we know it. That I will bet you $1 to a donut that we have that somewhere in our solar system.
I agree with you. And it could be under the South Pole of Mars as well, because they discovered
Yeah,
a large water reservoir, probably very salty, very briny, but it's under the Martian South Pole cap, and it's more than a mile in size. And it's
yeah,
water because it's under pressure from the overlying rock strata, so that water can be in liquid form.
yeah. Gosh, I tell
Cool.
you, we're getting down towards the end here.
Well, this has
This has
been
been,
great. I've had a good time.
yeah, this has been interesting talking about all the stuff that we know and what we don't know.
And stuff we don't know.
Yeah,
That's right.
I personally think the stuff that we don't know is more interesting than what we do know.
I don't disagree at all. I think that is why I do what I do. It's why you do what you
Yeah,
do, right?
yeah, yeah,
Yeah, this is great stuff. I
yeah.
want to thank your viewers too for
And
you
I
know,
would tell people where they can get a hold of you, communicate with you, or if you have publications that you need to let people know that you have, and
oh sure.
website.
I wrote a book called The Populated Universe. It's about the subtext is life in the universe may very well be the rule, not the exception, and it basically talks about where life on Earth came from, and it also talks about the possibility of life on other worlds. And a lot of this stuff we've talked about, some of it is covered in there. But if you want to see our live universe live in real time that we do on clear nights, and other than the full moon, we will actually stream live. And we have two observatories in the Arizona desert. We stream them live and we show people a beautiful night sky. And we take photographs. I talk to people in the chat. Um, and we actually give away all those photos to anyone who wants them. And you can find us at skytourlive.org, or as you said before, skytourlive.com. And we're on YouTube at SkyTour LiveStream with Marc D'Antonio. And the only reason I added my name was because somebody tried to pirate the site, but they couldn't pirate it with my name. So I added the name in, you know.
Okay,
Yeah. So
all right.
skytourlive.org, you find us, and SkyTour Livestream on YouTube. And that's where we are.
Yeah, and since I mentioned that it was more interesting with the stuff we don't know, is it goes right back to what Albert Einstein said one time. He says, imagination is more important than what we know because what we know is locked down with facts. Our imagination can create absolutely anything that we later on can create
And
and
I have
make
said
fact.
often, Augie, you're right. I have said, I don't believe that the mind can imagine anything that can't be created.
Yeah,
Yeah.
well, we're
That's
on the
my
same.
theory, and I'm sticking to it.
Yeah, I'm sticking to the same theory.
Yeah, good for you.
All right. Well, gosh, oh, I got a question for you that I didn't tell you because I wanted to blindside you.
Go for it.
The question is, if you could talk to the whole world and the world is listening, what would you tell them?
Oh boy, that's a good question.
Yeah.
I would tell them that uh, for those that could understand, and probably let's assume everybody does, I would say we have to keep our eye in the skies. We also have to keep our eye on learning science because it's the rigorous application of science that is going to get us off this world someday.
Yeah. Well, we're off the world, but we're not very far.
Hmm. I know.
And people at NASA say we don't know how to go to the moon because we don't know how to go through the Van Allen belt yet. Well, they did,
We did
didn't
in the
they?
60s. Yeah.
Yeah.
They went
Oh,
out through the
that's what.
North Pole. That's like how it worked. They went through the North Pole where it was thinnest and the least exposure for the astronauts. So they still went through these charged particles trapped in our magnetic field, which is the Van Allen belt.
Yeah.
But they went out in an area where it was the thinnest, and that was where the poles were.
Yeah.
Yeah.
But they still had to travel all the way through to the moon, and there's radiation out there too. So
Yep. Yep.
I still got questions on this one.
Well, you got to have me back.
Yeah.
You know,
That would be
when I
good to
did
discuss.
Yeah, if people want to see more of what I do, they can watch History Channel and the show called The Proof Is Out There.
Hmm.
I've been in every season of that series so far as their chief photo and video analyst, and I've been in NASA's Unexplained files. I've been in What on Earth, and for What on Earth, I did a story where they had Apollo astronauts put on a dark helmet so they could track cosmic ray strikes on their retinas. Something we don't get to see here on the planet too much, but out in space, they're very common.
Yeah. Yeah. Okay. Well, thank you very much for being with us. And yeah, we got to talk a little bit about the moon and maybe a little more about what's going on out there too.
Whatever you like. I
Yeah.
want to thank
Sounds
your
great.
listeners and viewers too. It was really fun. Thank you very much, guys.
Yeah. Thank you very much.
Okay. Good night.
Yeah. Yeah.